Starting now.
Okay. So firstly, I would like to thank Space Habitat event team for providing us such an opportunity to present this at this great event. Secondly, we would like to thank our mentor, Dr. Sudhir Kumar Chaturvedi, for providing us such an opportunity to participate in this event. Moving on with the presentation, our team for the Space Habitat event 2021 is Dr. Sudhir Kumar Chaturvedi, who is our mentor, Alinda, and me, Janhavi. So moving on further with the topic of our presentation, which is the electromagnetic wave propagation in fractional space. Now, when we are looking forward for the topic, which states electromagnetic propagation within fractional space, then firstly we're supposed to study what is electromagnetic wave, right? So electromagnetic waves are used to transmit long, short radio waves, wireless signals, or energy. They also transmit energy in form of infrared, ultraviolet radio, and gamma rays. So some of the few properties of electromagnetic waves are all the electromagnetic waves are transverse. They do not require any medium to travel though. They travel at the speed of 3 multiple by 10 to the power minus 8 in vacuum. They can all be reflected and refracted. They can all be emitted and absorbed by matter. So the communication involves transmission of information from one place to another to electromagnetic wave. This is how electromagnetic wave propagation works. So let me give you a brief about how are electromagnetic waves propagated. So electromagnetic waves can be generated by a variety of methods, such as discharging spark or by an oscillating molecular dipole. Visible light is a commonly studied form of electromagnetic radiation and exhibits oscillating electric and magnetic fields whose amplitudes and directions are represented by vectors that undulate in phase as sinusoidal waves into mutually perpendicular or orthogonal places. Depends. This tutorial, like this thing, the presentation and the means of a topic, like the electromagnetic wave propagation of a virtual electromagnetic wave, and considers the orientation of the magnetic and electric field vector. The process of communication involves the transmission of information from one location to another. As we have seen, modulation is used to encode the information onto a carrier wave and may involve analog or digital methods. It electric fields. From its origin, the wave will propagate outwards in all directions. If the medium in which it is propagating, air, let's take for an example, is the same everywhere, the wave will spread out uniformly in all directions. Now, moving on further with the importance of electromagnetic wave, I'd like Alinda to carry on.
So why do we study electromagnetic waves? What is its importance? So EM waves is all around us. In simple terms, every time we turn a power switch on, every time we press a key on our computer keyboard, or every time we perform a similar action involving everyday electrical device, EM wave comes into play. It is the foundation for the technologies of electrical and computer engineering, spanning the entire electromagnetic spectrum from DC to light, from the electrical and magnetical based technologies to the electronic technologies, the photonic technologies. As such, in the context of engineering education, it is fundamental to study the electrical and computer engineering. Some 0.01% of energy of this entire universe is present in the form of electromagnetic radiations, be it communication or medical. It's dependent on each other, some or the other way, be it transformation of solar energy by photosynthesis into plants, to be it sun electromagnetic energy, helping living organisms to see the phenomena spreads out all over. Radio waves used for television and radio, which can be produced by oscillation in electrical circuits, microwaves used for satellite communication, infrared used for heaters and in cameras, and many more. Moving to the next slide. Now, to study our topic, we decide to refer three different papers. This is the literature review we did to make our study more clear. The topic of the first paper we referred is Differential Electromagnetic Equation in Fractional Space by M. Zubair and M. G. Mughal. In this paper, we studied that the study deals with the approach of fractional space generalization of differential electromagnetic equations. These equations can describe the behavior of electric and magnetic fields in any fractal medium. A new form of vector differential operator, del, and its related differential operators is formulated in fractional space. Using all these differential operators, we studied the classic Maxwell equation that has been worked out for fractal media. The conclusions that we derived from this paper were the novel fractional space generalization of the differential electromagnetic equation was studied that helped us to study the behavior of electric and magnetic fields. The differential electromagnetic equations in fractal space were established in this work, provide a basic for application of the concept of fractional space in practical electromagnetic wave propagation and scattering phenomena in far field region of any fractal medium. Now, I would like Janhavi to continue further.
So this is the second paper we referred for our literature review, the topic of which is the research on electromagnetic wave propagation in fractional space, which was published in Third International Conference in Material 2015. So in this paper, a generalization of differential electromagnetic equations in fractional space is taken. These equations can describe the behavior of electric and magnetic fields in any fractional media. The time evolution of the fractional electromagnetic waves by using the time fractional Maxwell's equations, as described by Alinda in the referred paper number 1, has been investigated in this particular paper. The theoretical analysis shows that the amplitude variations of the general plane wave solution not only is related to Bessel's functions, which is clearly mentioned in the paper if you go and refer this paper, but also reveals an algebraic decay at asymptomatically large times. So the conclusion that we can draw in short from this paper is we discuss the time evolution of the fractional electromagnetic wave in fractional space. Also, the amplitude of the general electromagnetic wave exhibits an algebraic decay with increasing time. So a particular graph is mentioned, which you can refer to in this paper. Now, moving on to the paper number 3.
The third paper that we referred for the literature review is Fractional Space Waves in Conductors. In this paper, we studied the mathematical analysis where the concepts of integral and derivative operators of integers were placed. In this paper, the basic tools were to solve the differential equations that we need for additional conditions in order to produce a unique solution. The fractional space waves in conductors were analyzed using basic ohmic conductors, and various analyses were made. The conclusions that were made through this paper was the analysis of the fractional space waves in conductors from the point of view of the fractional capsulate. It is a derivative which is used to and the order of the derivatives. In particular, in this paper, a model of dimensional fractions wave equations were considered in detail. When we will go through this paper, we come across various mathematical models which helped us in the better understanding of Maxwell's equations and the various basic electrical formulas that we can use in space for electromagnetic studies. In the case, different gamma ranging was studied for electric and magnetic fields which exhibits an exponential behavior, and the displacement of the fractional oscillation motions were also studied. All these solutions were over a small range of parameters and are universally accepted. The methodology that were presented in this paper are applied for critical phenomena theory and are in self-similarity. Now, among various problems for further research, which are mentioned in this paper, we came across 2 and 3 different fractional wave equations that are considered for fractional variation calculus. Through this paper, we came across many new things, and it was really helpful for our study. Janhavi, please go ahead.
Thank you, Alinda. Now, for the future goals, future advancement in the field of EM waves in fractional space are basically to examine the solutions for radiation problems in fractional space. So there has been much interest to study different physical phenomena in fractional dimensional space. During the last few decades, it has been a major run for many authors and many scientists, I'll say. The concept of fractional space is used to replace the real anisotropic configuring structure with an isotropic fractional space, where the measurement of this confinement is given by fractional dimension. In the recent years, fractional calculus has attracted many researchers successfully in different disciplines of science and engineering. Now, this is a new thing which came out for a topic like this, which was fractional calculus, which was to define the electromagnetic waves in fractional space through particular equations. Those equations were named as fractional calculus. Those equations, the whole term that they explained was termed as fractional calculus. Now, one of the main advantages of this fractional calculus is that the fractional derivatives provide a superior approach for the description of memory and heredity properties of various materials as well as the various processes which we use. Applications of fractional calculus in the field of mathematics, chemistry, physics, biology, and engineering have gained considerable achievement, and many significant results were obtained, and many more are yet to come. So some materials and media that have electromagnetic memory properties can be expressed by fractional calculus, fractional non-local formalism, which is basically there were a few formulas in the fractional calculus provided to define this particular topic, which is very heavy, in a simpler equational form so that people can understand it and use it in the further theories. Therefore, the generalized fractional Maxwell equation can give us many new models that can be used in complex systems. In the last few decades, there has been interest in physical description of confinement in low dimensional systems, assuming a fractional dimensional of the space. The idea to take place of the real confining structure by a space where the measure of confinement or anisotropy is given by non-integral dimensions. The aim of this work is to study the time evolution of the fractional electromagnetic wave by the means of time fractional Maxwell equation in fractional space. For this purpose, there were a few differential Maxwell equations form presented for this fractional space thing, and which is very well mentioned in the referred paper. We have given the names and the author's name and the year of publishing and everything provided. The details are very much clearly provided. So you can refer that for these equations and these details. Now, I hope you like the presentations. Now, thank you so much for providing us this opportunity. These are the contact numbers of me and my team member, Alinda. And I think that is it from our side. Thank you so much. If there are any queries, they're most welcomed.